Quick Electronics 101. What is a fuse? To begin with, we need to know the purpose of a fuse. There are a lot of different types of fuses, and the most common one is this cartridge fuse. Fuses are overload protection devices. Standard fuses have a thin wire that will melt when exposed to a high current. Fuses are single-use devices, meaning that once the fuse wire melts, it cannot reform itself. We need to replace the broken fuse with a new one manually. A fuse is made of a metal strip or a wire fuse element. When the current starts flowing through the fuse element, heat is generated due to the resistance of the fuse element. A fuse element is constructed in such a way that when a normal current flows or a small current spike occurs, it does not cause the fuse element to attain a high temperature. But when the current load is too high, the fuse element rises to a high temperature and melts. When the fuse element melts, the circuit is now open, which means that the high current will not reach the electronic devices, preventing damage or, in the worst case scenario, starting a fire. Now, how can you tell if a fuse is in good condition? We need a fuse and a multimeter. In your multimeter, turn the dial to continuity test mode. It will likely share a spot on the dial with one or more functions. In my case, it is in resistance. After that, put the alligator clip on each side of the fuse. If we do that, we should get a reading on the screen other than OL, and in my case, I get an audible sound indicating that the 2 points are electrically connected. However, if the reading stays in OL, which means open loop, and we do not get a beep sound from the multimeter, it only means that the fuse element is already melted. Next, how are we going to know the right value of fuse to put in our circuit or appliances? The simple calculation is that P divided by V is equal to I. After you have calculated this, always remember the recommended method, which is to use the 700 watt rule. For an appliance rated at 700 watts or less, a 3 amp fuse should be used. For appliances above 700 watts, a 13 amp fuse should be used. As an example, we'll be looking at the rating plates of two devices. The rating plate will tell us the power rating and operating voltage of the device. The first device is a studio light, and like I said, we will be using the equation I is equal to P divided by V. P is power, which in this case is 50 watts, and V is voltage, which in this case is 265 volts, which equals to 0.18 amps. So therefore, a 3 amp fuse should be more than capable of handling the current required before it fails. The second device is a microwave oven with a power rating of 1200 watts divided by 230 volts, which equals to 5.21 amps. So therefore, a 13 amp fuse should be more than capable of handling the current required before it fails. If you have no electronics component yet, you can visit the PET simulation website and try to experiment with the fuse there. And as always, keep learning and have fun. Bye!